The law of sines tells us that for any triangle where side little a is opposite angle big A, side little b opposite angle big B, side little c opposite angle big C, that we have side A over the sine of angle A equals side B over sine of angle B equals side C over the sine of angle C. That the ratio between the side and the sine of the angle is the same all the way around the triangle. It makes a certain amount of sense that that might be true because a larger angle will have a larger value of the sine and will tend to have a larger side over here. But the fact that it works all the way around the triangle and works precisely takes some work to prove. We also state the law of cosines for completeness, although we've seen the law of cosines. For this triangle, we would say that c squared equals a squared plus b squared minus 2ab cosine of big C. Also that a squared equals b squared plus c squared minus 2bc cosine of big A, and so on. So those are the three ways in which the law of cosines could be stated. And this is the law of sines. And any two of these could be set equal to each other. Now, how do we use these laws? Let's consider the triangle that you see here, where we have the sides as labeled. And I think we're missing a piece of paper to buffer this. You've seen a lot of show through there, so let's fix that. Okay. We have an angle of 26 degrees and a side of 14 units here. Then a side of 21 units here. I'm not sure what I'm saying about no Pythagorean theorem implies B, because there's no assumption of a right triangle. I'm not sure. That note meant something, but let's ignore it for the moment. And then we'll see if we can make some sense out of it. However, knowing angle A and side A makes sense to say that, well, since we know this ratio, sine A over A, and since we know side C, then we know sine C over, well, we know side C, then by setting sine C over C equal to sine A over A, we're going to be able to solve for the sine of C. And in doing so, we obtain sine of C equals C over A times the sine of A. And that's easily solved for angle A, as we'll see in a minute. Now let me point out one thing. Whether you put the sine on top or on the bottom, or whether you put the side on the bottom or on the top, depends on what it is you're trying to solve for. In this case, we're trying to solve for sine C, so it's a lot more convenient to have the sine of C in the numerator. If we were trying to solve for side C, we would probably invert this and say side C over sine C equals side A over sine A. Anyhow, in this case, since we're solving for sine C, we just have to multiply by little c to obtain the formula for the sine of C, and then we simply plug in the values of side A and angle A and side C. So that C over A times the sine of A becomes 21 over 14 times the sine of 26 degrees, or 0.652. We then easily solve for side C by taking the inverse sine of both sides. Side C is 41 degrees. But that's not the only solution. That's not the only possible solution. Now this is an ambiguous case, it turns out. We say that the sine of C is 0.652. 41 degrees is one solution to the equation sine C equals 0.652. 180 degrees minus the inverse sine of 0.652, or 139 degrees, is another solution. And you can see that by looking at the reference triangle. There are two angles that give us a sine of 0.652, a first quadrant angle and a third quadrant angle. And both of those angles are valid solutions to this equation, and might well be valid solutions in the case of this triangle. There might be another triangle with a side of 14 and an angle of 26 degrees, where this angle C is 139 degrees instead of 41. So there might be two angles, one with 41 degrees, one with 139. That would correspond to the side C coming in and intersecting about here, and then having it rotate out to where it intersects a line in the 26-degree direction out here someplace. Now there's a lesson in that, and the lesson is if you use the law of sines to find an angle, you're going to get an ambiguous answer. You're not going to know whether the angle is less than 90 degrees or greater than 90 degrees, 41 degrees or 180 minus 41 degrees. Therefore, if at all possible, you should use the law of cosines to find angles. Of course, in this case, it's not possible to do that. We did the best we could here.